and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Re-Level. So now in this video, we are going to continue on our series and talk about the third scheduling algorithm, which is priority-based scheduling. Here, as the name suggests, we are going to give a lot of importance to the priority of the process for its execution. So let's take a look. Priority scheduling is a method of scheduling processes based on priority. In this method, the scheduler selects the tasks to basically work as per the priority. Now, priority scheduling also helps the operating systems to involve priority assignments. The processes with higher priority should be carried out first, whereas jobs with equal priorities are carried out either on a round robin or a first come first serve basis. So if there is a process with higher priority, it will execute first. But if there are two processes with the same priority, you can either choose the first come first scheduling, or you can choose the round robin scheduling as well, which we will talk about in the next video. Now, priority can be decided based on memory requirements, time requirements, etc. Okay, so what happens is, always remember that the priority of a process which is internally decided can often be based on the memory requirements, time limits, number of open files, the ratio of input output burst to the CPU burst. Okay, anything, or there are a lot of internal factors which decides the priority of a particular process. Okay, as in what we discussed with the first come first serve scenario, what we can also say is that in priority scheduling also we have two parts. Okay, priority scheduling could also be non-preemptive, and it could be preemptive as well. Similar to shortest job first that we discussed, which could also be preemptive and non-preemptive. Okay, so here in what happens in the priority scheduling is, we give importance to the priority of the process. Every process is basically scheduled according to the priority number. So every process will be given a priority number, and based on the priority number, you will basically schedule the processes. Generally, although you can follow any rule that you want, generally we can say that lower the priority number, right, higher the priority. Okay, that is what the general rule is. And when we talk about non-preemptive scheduling, right, in non-preemptive scheduling, the process gets scheduled and it will run till its completion. It will run till its completion happened. No other process can interrupt the running process and basically schedule the other process. Okay, so let's quickly take an example and understand this. So we have the process. I'm going to take a bigger example this time. We have the process P1, P2, P3, P4, P5, P6 and P7. I also have the priority for each and every process, which will be 2, 6, 3, 5, 7, 4 and 10. Along with that, we also have the arrival time, which will be 0, 2, 1, 4, 6, 5 and 7, and we also have the burst time. Now you need to be very attentive while listening this, because we've added a lot of things over here. 3, 5, 4, 2, 9, 4 and 10. Okay, this is what it is. And now we'll take an example of how the non-preemptive scheduling will work over here. And this will be the Gantt chart. Okay, so now what happens it at t equal to 0. Okay, at the arrival time, we only have one process over here, right? Which is P1. Okay, so here at t is equal to 0, only the process P1 is basically existing with a burst time of 3 units. Okay, and here what we are going to do is the priority of the process is 2. But since there are no other processes right now, we are going to execute it immediately. So here P1 process will basically get executed from 0 to 3. Okay. Now what happens it by the time t is equal to 3, right? We have the process based on arrival time. We have P2 and P3 also over here. Okay, because their arrival time was 1 and 2. But here in these two processes, the priority of P3 is higher. Hence, we will execute P3 over P2. So P3 basically will get executed, okay, with the burst time of 4. So this and this are done with the burst time of 4. That means this goes till 7. Now by the time of t equal to 7, all the processes, this and this, all are available in the queue, right? Now after this, what we will see is that the priority of the process, right, lower the number, higher the priority. Okay, and this are basically already done. Out of the left processes, the process P6 over here, okay, is basically the one which has the highest priority 4. So P6 will get executed, and at t equal to 11, P4 will be P6 will be done with the burst time of 4. Okay, so this is also done. Next, which is the process, no new process came in, and with the available process, we can say that P4 was basically having the highest priority with the burst time of 2. So this is 13 and this is P4, and now this process is done as well. Okay, see, it is non-preemptive, so nothing is interrupting the execution of the current process. Now the next one that we have is 6, 7 and 10. So P2 is the one with the lowest priority over here. So we will execute P2 with the burst time of 5. So this will come out to be 18 over here. Okay. So this is also done. Now after this, 7 is the one with the highest priority. So we can have 9 over here, which will be 27 for P5. So this will be this. And the last one that we have is P7, and this will be 37. Okay. So this will basically be our way of executing these processes. Okay, based on the priority. So you see if the process, what all process have arrived for a particular period of time, and based on that you take the call which process is to be executed based on the priority number. Okay, and what formulas did we discuss? We discussed turnaround time, which is nothing but completion time minus the arrival time. Okay, so first of all, let's mention the completion time for every process. This is the burst time, this is the completion time. The completion time for P1 will be 3, the completion time for P2 will be 18, the completion time for P3 will be 7, for P4 it will be 13, for P5 it will be 27, for P6 it will be 11, for P7 it will be 37. Okay, let's verify if it is Correct or not? Looks correct to me. Next, what we have will be the turnaround time, which is nothing but completion time minus arrival time, correct? So when we do this, we get 3, 16, 6, 9, 21, 6, and 30. This will be the total turnaround time over here for each and every process. And we know that the final formula for calculating the waiting time, which we've already taken a look at the last video, would be turnaround time minus the burst time. So here turnaround time minus the burst time, 0, 11, 2, 7, 12, 2, and 20. This will be the waiting time for each and every process that we have. And based on that, what will be the average waiting time? It will be 0 plus 11 plus 2 plus 7. Plus 12 plus 2 plus 20 divided by 7, which comes out to be 52 by 7 over here. Okay, and to give you the exact number, that will be approximately 7.42 milliseconds. And remember, this is how you have to solve all the questions, because if you don't solve it this way, trust me, you will never get the right answer. And if your understanding regarding the process is not clear, regarding the algorithm is not clear, then also it's pretty sure that you are going to make errors. So make sure you remember the formulas. These two are the most important formulas that you need to remember, because these two formulas actually derive all the other formulas as well. You understand very clearly and you take care of the fact that whenever you are scheduling the process based on the arrival time. Okay, because arrival time is important. It may so happen that the process has a very high priority, but it hasn't really arrived yet, right? So it's not possible for you to schedule it. This is the concept behind priority scheduling in terms of non-preemptiveness. Let's also take an example of preemptive priority scheduling. Okay, so what happens over here is, in preemptive priority scheduling, at the time of the arrival of the process in the ready queue, its priority is compared with the priority already present in the ready queue, as well as the priority with the process which is currently executed. So what we used to do in non-preemptive is, there is a process, you compare its priority with the process in the ready queue and then execute. But in terms of preemptive, you also compare it with the priority with the process which is currently executed. So let's say there is a process with priority 10 that is being executed, but suddenly a process with priority 3 comes. So in that case, what happens is, you have to stop the process with the priority 3 that is being executed and instead execute the process with the priority 3. Okay, so here remember that a process can be stopped in between which is being executed in case of a arrival of a higher priority job. So remember over here, let it get saved. So in this case, what can happen over here is, a job which is being executed can be stopped in between at the arrival of a higher priority process. Okay, let's take an example here as well and understand how it works. Process priority arrival time burst time. Process again is P1, P2, P3, P4, P5, P6 and P7. Okay, here let's say the highest priority is 1 over here. Then we have this process with the next highest priority. Then we have this process with the next highest priority. Then we have this process with the next priority over here. Then we have this process over here, and no, let's do one thing. Let's keep this with the highest priority. Then let's keep this with the second highest priority. Then let's keep this with the third highest priority, fourth highest priority, six and 5, and then we can have the fifth highest priority. Then we can have sixth highest priority, and the lowest priority is arrival time is 0, 1, 2, 3, 4, 5 and 15. Okay, and burst time is 1, 7, 3, 6, 5, 15 and 8. Okay, now let's see the Gantt charts. We are basically at t is equal to 0. Now at t is equal to 0, we just have one process P1, right? All this priority is lowest, but we do not have any other process. So till 1 unit of time, this process will get executed. Now at t is equal to 1, we have another process P2 also over here. Okay. Now in this point of time, what will happen is the process P1 has completed its basically, I would say, execution as well, because there was only 1 unit. Okay, so this process is completed also, and at t equal to 1, what will happen is another process comes as well, which is P2 over here, and here basically this process will get executed because at t equal to 1 there is no other process. So here P2 will basically get executed till t is equal to 2. Now at t is equal to 2, you have two processes over here. Okay, and the burst time for this is basically left with 6. Now a process over here P2 comes. Okay, now in this case what will happen is the priority of P2 is 3 and the priority of P3 is 6. Now over here what happened is till the time of t is equal to 2, we have these two processes, and out of these two processes the priority of P2 process is basically higher. So P2 process will keep on executing over here as well, and this is at t is equal to 3. Now at this point of time we have still to execute 5 more units of this. Now at t is equal to 3, we also have this process over here. Still the priority of P2 process is higher over here. So in that case what will happen over here is P2 will keep on executing. At t equal to 4, this process still has 4 units left to execute. Okay, at t is equal to 4, we have all these processes. Again P2 is basically having the highest priority, so P2 will basically get executed. Now at t is equal to 5, I still have 3 more units left to execute. At t is equal to 5, we have all these processes over here, right? Now out of these, which one has the highest priority? I can say that here the priority of the new process which came in is the highest. So what you will do is you will halt the process P2 in between and the execution of the process P1 will execute. Okay, so P1 will execute, and no matter after that what other process comes in, it does not matter, because over here, although this process P1 came at 15, right, but still P1 will get executed. So P1 comes over here at t is equal to 5, is the higher priority process. No other higher priority process we have over here. So it will keep on executing. So it will start at t is equal to 5 and it has a burst time of 15. So I think let's say it will stop at t is equal to 20. Okay. Until that time, the P1 process will keep on executing. So this is also done. And by this point, all the processes have actually arrived with their left burst time as 3, 3, 6, 5 and 8. Okay. Now out of all of these processes, which process has the highest priority? It is the P7 process. So P7 process will execute fully because there is nothing to block right now. So it will take 8 units. So at t is equal to 28. T is equal to 28, you will have P7 process. Okay. Now after this, what will happen is you will have the next process. This is also done, which is the next hierarchy process, which is P2. So P2 will basically get executed till 3 units, 31. Now this is also done. Now we will next execute P4 for 6 units. And then what we have is P5 for 5 units. And then the last one that we have is P3 for 3 units. And this is what the entire way is of executing the processes. As you can see, similar to the previous process, we can stop a process in between, and we will take care of the execution of other process if a higher priority process comes in. Okay. So you can take a look over here and see how this is really working. If at a certain point of time, some higher priority process comes in, the execution of the lower priority process gets stopped. Okay. Now first we will mention the completion time over here. The completion time for P1 is 1. The completion time for this is all P2 only. Okay. You don't have to keep this. The completion time for P2 is basically 31. The completion time for P3 is 45. The completion time for P4 is 37. The completion time for P5 is 42. The completion time for this is P6, not P1. P6 is 20 and the completion time for P7 is 28. Okay. Using this, we can calculate the turnaround time. The formula for that was completion time minus arrival time. So this is 1, 30, 42, 34, 38, 15, 13. And the final is the waiting time, which is nothing but turnaround time minus burst time. So this is 0. This is 23. This is 39. This is 28, 33, 0, 5. Okay, and what will be the average waiting time? 0 plus 23 plus 39 plus 28 plus 33 plus 0 plus 5, which will come out to be 23 plus 39 plus 28 plus 33 plus 5, which is last one is 0. This is 128 by 7, which is 18 something. Okay, milliseconds. So this is what your final answer is regarding the preemptive scheduling of the algorithms. Okay, so I hope both the processes are now clear at well, the preemptive part and the non-preemptive part over here. Okay, one important thing to remember over one of, I can say, a disadvantage of using preemptive and priority scheduling is that what if there is a process with a lower priority? Okay, and what if it is not getting executed because higher priority process keeps coming and coming, because of which what will happen over here is that it will lead to a condition of starvation. There is a process with priority 10, but it is not able to execute because higher priority process keeps on coming and coming. So what happens in this situation? This is a situation of starvation or infinite blocking. Okay, a process is ready to execute, but it is constantly being blocked because new higher priority processes keep coming in, because of which the lower priority process is waiting for a very long time in the priority queue, and it may have to wait for very long time as well. Okay. To solve this problem, we have a few techniques, for example, aging techniques and some other techniques using which you can tackle this problem as well. But you should know that there is a such kind of a problem which actually exists regarding priority scheduling. Okay. So that's what pretty much the idea about priority scheduling is. I hope you were able to summarize the overall idea as well. It just schedules the process based on its priority. And again, it also have two types, non-preemptive and preemptive. Okay. So please make sure you try out some more examples related to this as well in order to be 100% sure whether you're clear or not. And now I'll definitely meet you in the next video where we are going to talk about the next scheduling algorithm, which will be round robin scheduling. So stay tuned for that video as well. Thank you.